Okay, so in this video I'm going to have a look at the 2022-2023 higher level applied maths sample paper, question 1. So we have a directed graph and it's represented by the adjacency matrix M, which we're given here. Draw the graph represented by M. So the way this works is you've got A, B, C down along here. So you've got A, B, C along here, and you've got A, B, C along here. And we've just got to draw the graph represented by these three nodes. So let's have a look at that. So from A to A, there are no paths. So we're just going to draw A here. From A to B, there are no paths. So we're going to draw B out here. From A to C here we can see there are two, so we'll draw C down here, so we can draw two paths down along here. In that it's a digraph, so we've got to draw the direction as well. So from B to A, so this is B, this is A, so from B to A there is one path, we can see that here. So from B to A there's one, so we can draw a path here. We've got to put in the arrow as well. From B to B there's one as well, so that's just going to give us this kind of loop here. Put an arrow in there as well. And from B to C there are none. From C to B there is one, so we've got to draw a path up along here. And from C to C there are none either. So that's it really, that's our final graph. Okay, so the next thing we've got to do is calculate m squared. So we've got to take this matrix here and we've got to square it. So let's do that. So our matrix is 0, 1, 0, 0, 1, 1, and then we've got 2, 0, 0 here as well. So let's just multiply that by itself. Okay, so we start by multiplying 0 by 0, 0 by 1, 2 by 0, add your three answers, and that's just going to give us 0. So our first entry here is just going to be 0. Then we multiply 1 by 0, 1 by 1, 0 by 0, and that'll just give us 1 when we add those three together. And then finally down here, 0 times 0, 1 times 1, and 0 times 0 is just going to give us 1. We now start with this column here, so we go 0 times 0, 0 times 1, 2 times 1, so that's just going to give us 2 when we add those together. So 2 goes up here. Now we've got 1 times 0, 1 times 1, 0 times 1, that's just going to give us 1. We've got 0 times 0, 1 times 1, 0 times 1, that's 1. And finally we just come out here to this column. We do the same thing again, 0 times 2, 0 times 0, 2 times 0. So that's going to give us 0. We've got 1 times 2, we're starting here now, 1 times 2, 1 times 0, 0 times 0, that'll give us 2. And then down here, 0 times 2, 1 times 0, 0 times 0, that'll just give us 0 down here. So this is m squared. So this is m times m to give us m squared. Okay, what information is provided by the elements of m squared? So what does this matrix here tell us? Okay, so m squared shows the number of walks of length 2 between the nodes or vertices. So for example, if we look at, let's say this one here from A to B, there are 2 walks of length 2 between A and B. So let's have a look at that. So from A to B, I should say. So from A to B, you can go down this way and then up this way. That's 1 walk of length 2. You can go down this way and then up this way. That's another walk of length 2 from A to B. So that's that. Part B then, let's see, what have we got? We've got a gardener who plants a new fruit tree which has 3 new branches. And in a branch's first year of growth, it will not produce any additional branches. Each branch will produce one additional branch every year after that. Okay, so the gardener models this growth pattern by defining UN to be the number of branches on the tree n years after planting, with U0 equal to 3 and U1 equal to 3. Write down the values of U2 and U3. Okay, so what I might do here is just draw the tree maybe. So let's say we have a branch coming out here and a branch coming out here. So that gives us 1, 2, 3 branches, let's say. Now that's U0. So at the beginning we have 3 branches. So after 1 year we'll still have 3 branches. So U1 is equal to 3. Now U2 then, let's put it in red. So this branch here will grow another branch. This branch will grow another branch, and this branch here will grow another branch here. So if we look at it now, we've got 1, 2, 3, 4, 5, 6 branches on our tree. So in red here we have 6. Okay, 3 extra branches. Now let's look at U3 then. So these red branches here that I've drawn here are not going to produce another branch this year, but the black ones here will. So we're going to end up with another branch here, another branch here, and another branch here. So that'll give us 1, 2, 3, 4, 5, 6, 7, 8, 9. So U3 then will be 9. Now we could go on and do another one. We were not asked for it in the question, but let's do another one anyway. Let's say U4. So U4, remember our green branches won't produce any more branches, but the other 2 will. So we should end up with, we should get another branch from the red branch and the black branch. So 1 here and 1 here. So 1 here and 1 up here as well. So that'll give us a total of 1, 2, 3, 4, 5, 6, 7, 8. That's a branch there. 9, 10, 11, 12, 13, 14, 15 branches now. So at this stage we have 15 branches. So U4 is 15. And at this stage you can probably see what's happening. You can see that it's, if we add these 2 here we get 6. If we add these 2 here we get 9. If we add these 2 here we get 15. So the number of branches is really the addition of, or the sum of, the number of branches added together for the previous 2 years here, previous 2 terms. So that's it really. This is our answer here. We were asked for U2 and U3, 6 and 9. So the next thing we've got to do is write down a difference equation in terms of UN plus 2, UN plus 1, and UN. So let's do that. So we have UN plus 2 is just going to be equal to UN plus 1, previous term, plus the previous term, which is UN. So that's our difference equation. And the next thing we've got to do is solve this difference equation. Solve the difference equation. So our difference equation is UN plus 2 minus UN plus 1 minus UN, and that's equal to 0. Just move this down a little bit here. And let's just solve this particular difference equation. Now let's just write down the characteristic quadratic equation first. So it's going to be x squared minus x minus 1 is equal to 0. So we're not going to be able to factorize this, so what we've got to do here is use the quadratic formula, the minus b formula. So our a is 1, our b is minus 1, our c is minus 1. So we know now that x is going to be equal to minus b, which is minus minus 1 plus 1, plus or minus the square root of b squared minus 4 times a times c all over twice a. So we'll get 1 plus or minus the square root of, this will give us plus 1, this will give us plus 4, so it's just the square root of plus 5. So these are our 2 solutions here for x. So let's just put that into our formula. So we know that un then is our two roots are different, so our un then is just going to be equal to L times alpha to the power of n plus m times alpha to the power of n. So we have L times 1 plus root 5 over 2 to the power of n plus m times 1 minus root 5 over 2 to the power of n. So this is our solution here. We just now got to work out what L and m are. So in order to do that, we're going to use our u0 is equal to 3, and our u1 is also equal to 3. We'll use that as well. So if we put in 3 here for our un, and put in a 0 here and a 0 here, because that's our n, this is our n here, 0. So this will all just become something to the power of 0, which is 1, so that'll just leave us with L here. This will all become 1 as well, so we just get L plus m. So that's our first equation, okay? Let's look at our second one then. So we've got u1 is also equal to 3. So 3 is going to be equal to L times 1 plus root 5 over 2 to the power of 1 plus m times 1 minus root 5 over 2 to the power of 1 as well, and this is our second equation here. Now we've got to use simultaneous equations to work out what our L and m are. So I'm just going to have a look at equation 2 here, and what I'm going to do is just multiply across by 2. So that will give me 6 is equal to L times 1 plus root 5 plus m times 1 minus root 5. This is equation 2 still here. I'm going to take equation 1 and I'm going to multiply it by minus 1 plus root 5. So we'll end up with minus 3 times 1 plus root 5 is equal to minus L times 1 plus root 5 minus m times 1 plus root 5. Okay, so what I'm going to do now is just add these two equations here, and you can see that this will disappear here. We've got a plus L, a minus L, 1 plus root 5. So let's just put a line underneath here, and what we end up with is we end up here with 6 minus 3 times 1 plus root 5 is equal to, this will give us 0. We end up with m times 1 minus root 5 minus m times 1 plus root 5. Okay, so let's just factorize out that m, I think. So I'll just move this down again. Okay, so we're going to factorize out this m here. So on this side we have 6. Let's see, we have 6 minus 3 root 5. And on this side then we've got 1 minus root 5 minus 1 plus root 5. And we've got an m here on the outside. So let's just sort all this out. 6 minus 3, 3 minus 3 root 5 is equal to, in the brackets then we've got minus 1 minus root 5 minus 1 minus root 5 all times m. So that'll give us 3 minus 3 root 5 is equal to 1 minus 1 is 0, minus root 5 minus root 5 is minus 2 root 5. And then finally over here we end up with m is equal to 3 minus 3 root 5 all over minus 2 root 5. Now I think I might just mess around with this one a little bit just to sort out that minus on the bottom. You don't really have to, but might make it easier later on maybe. So first thing I'm going to do is just call that 3 root 5 minus 3 over 2 root 5 is equal to m. All I did was multiply the top and the bottom by minus 1 just to get rid of that leading minus on the bottom here. So what I might do as well, actually, you don't have to, it's just to tidy up, get rid of this root 5 from the bottom here. What we'll do is just rationalize the denominator. Not absolutely necessary, but just to tidy it up. Let's see, we've got 3 root 5 minus 3 over 2 root 5. I'm going to multiply it by root 5 over root 5, just to get rid of that root 5 on the bottom here. So I'm just multiplying it by 1. I'm not actually changing the fraction, just multiplying the fraction by 1 in the form of root 5 over root 5. So we get 3 times 5, which is 15, minus 3 root 5 over root 5 times root 5 is 5, 2 5s 10. So this is what I'm going to use here. So I'm just box that off there. So that's what I'm going to do down here. So this just becomes 15 minus 3 root 5 over 10 is equal to m. That's my value for m. Okay, so let's move on then and look for L, or try and find L. So we know that L plus m is equal to 3. That's equation 1. So L plus m is equal to 3. This was our original equation 1. So we now know that m is 15 minus 3 root 5 over 10, and that's equal to 3. So our L then is just going to be equal to 3 minus 15 minus 3 root 5 over 10. So our L then finally is just going to be 15 plus 3 root 5 over 10. This you can just do on your calculator, or you can do it manually. Either way, you get your L here. So this is my M, and this is my L here. So my final solution to the difference equation is UN is equal to 15 plus 3 root 5 over 10 times 1 plus root 5 over 3 to the power of n plus 15 minus 3 root 5 over 10 times 1 minus root 5 over 3 to the power of n. This is the final solution here, if you like. Yeah. So that's it for that part of the question. Okay, let's look at the last part then. Plants must be cut back regularly to allow them room to grow. How many of the old branches should be removed at the end of year 4 to ensure that there are exactly 14 branches at the end of year 5? So I've just copied the diagram from the previous question, and we're going to look at U5. And U5, then we just got to add branches to everything except the blue branches. So we're going to end up with an extra branch here, an extra branch here, an extra branch here, 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 and here. So that should give us a total of 15 plus 9, which is 24. Let's see, 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we do end up with 24 here. Now at the end of year 5, we need to end up with exactly 14 branches, Now these 15 branches here from the previous year had 6 new branches which are not going to reproduce this year. So that will leave us with 9 branches. If you take 15 minus 6 is equal to 9. So these 9 branches will produce new branches. Okay. We've got to cut back a certain number of these 9 branches so that we'll end up with 14 branches here. So remember, we're starting with 6. We'll have these 6 new branches. So how many do we need then to make up the 14? We need another 8 to make up 14. So really what we're going to have to do is, from these 9 branches, we're going to have to cut back 5 of them to leave us with 4, and that 4 will double to 8 to give us this 8 here to leave us with 14 in total. So if we cut back 5 of these 9 branches, 5 of those 9 branches, that'll leave us with 4. Each of those 4 will produce a new branch to make up the 8 plus our original 6 to give us 14 branches in total at the end of year 5. So the answer here really is we need to cut back 5 branches. Okay. So that was the question, I think, how many of the old branches should be removed? So we need to remove 5 old branches. Okay, so that's it for question 1.